Hi, this is Johnny Nguyen. This is my demo and little explanation for assignment 1 for SRT521NAA. So, without further notice, or without stumbling over my words, let's just get into the code. But essentially, this is my first code. So I chose to use the integrated one, just seemed like it makes more sense. But essentially what I did was I went through all of the features and I basically compiled a list of headers I want to drop, and I dropped the headers and also axis 1 as well, and whatever is left off of that I basically just wrote it into another CSV. So cleaned.csv is what it's called. And then from there, so I used the select k-best to essentially narrow down the features, or just to show the best features essentially. But again, reading the CSV from what we created earlier from the previous Python code, dropping class and axis 1, but targeting class, just so that we can, so this is just getting the features and then targeting class. So scalar is an interesting one. So essentially what scalar does, it's a technique that scales all the features and gives it a range. So this is basically saying, oh, there's no negatives, and it's scaling between 0 and 1, and which is very convenient for me because I decide to keep all the features that were binary, so they're all 0 to 1, 0 to 1. So here's where I implement select k-best, variable name top features, and then select k-best, and I'm essentially using chi2 or chi squared, which is basically the, I want to say like an algorithm or a calculation to how select k-best is going to calculate the relationship between a feature and the target outcome. So it's this is how it ranks it, and this is selecting the top features right here, and then we just print the selected features. So I mean, I've demoed this in a previous lab, but I can demo it again just for demoing sakes, just so that you guys know it works. Yeah, so it prints out the selected features. Okay, and then moving on to my next code, which is the big bulk of this video. So importing modules, and then again reading the cleaned CSV. So this part, okay, so this part is interesting because I added this pretty much last minute, but essentially the column or whatever cell that contained unnamed was giving my code issues, or it was struggling to read. I think the data within it must have been, I don't know how to put it, it just, whatever was inputted into it isn't correct, or it's corrupted or something. So I essentially put this in to basically drop whatever whatever column or cell has unnamed. And then from there, we just drop class and axis 1 to get all the features, and we're targeting class again. And then here is where we're doing the leave out method. So we are splitting the entire data set into 2. So 20% is going into the training, the training split, and then the rest is the test. And random state is just whatever number you want it to be, really. So here is where we employ SVM, support vector module, or support vector, I'm pretty sure it's, support vector machine, and KNN. So here we're just setting the neighbors to 3, so the 3 closest neighbors for the prediction. and then we're having it fit into the x and y variables that we had for earlier, and then this is y predict. So however it's gonna, so this is just setting the variable for the prediction for the test, and then this is going to print the accuracy score, and then same case here but just for SVM. And then moving on, so this is where cross-validation happens for k-folds. So essentially, we're basically saying we're grabbing the cross-validation score for x and y, and we're setting this for 5 folds, 5 k-folds, and we want the scoring to be the F1. Sorry, my microphone just cut off here. And then here we're just getting the average, or sorry, we're getting the mean of the results for k and n5. Or k and n5 basically means the k and n with 5 folds. And then we just do it all over again for 10. This is, and then we do it all again for SVM for 5 and 10, just so that we have a more variance in terms of testing. So the leave one out, I couldn't get this to work, so I kind of just commented it out. It just kept breaking my my code, so I didn't even bother anymore. So here is where we actually where we get the classification report and the matrix, and I basically had it write to file. But yeah, so it's a for statement, so it's gonna loop for KNN and SVM, and we're basically just saying to, yeah, so we want to print the name, so that's KNN and SVM, and then the classification report. So this is going to print out for the Y test and the prediction that we have set for earlier, so on and so forth. And then yeah, the confusion matrix also prints out as well. So here is where we have the ROC curve figure created and then saved as well. So here we're basically setting, or we're basically getting the inputs or the results for the ROC curve. So the X and Y axis. And then here we're basically getting the AUC from the results from earlier. So this portion right here essentially is here, and the curve is being set right here. And then from there we just go on, we're just labeling, and then we just save, or yeah, we save the figure as that. And again, we have it for loop, so it's going to do it for both KNN and SVM. But I actually think I have the, you know, I'll just run the code again just so that there's an actual demonstration of this. But yeah, as you can see, prints out the accuracy, right? And it prints out the cross-validation for the k-folds. So 5 folds, 10 folds for KNN, 5 folds, 10 folds for SVM. So that's good. And then we also already had it pre-opened. But here's the matrix for SVM, and the matrix and the classification report for KNN, and then the ROC graph for both. So if I'm doing a general breakdown here, or analysis of the results, so both of the algorithms actually scored pretty high, both of them being over 90%. But K&N definitely had, or K&M scored definitely higher, with just being 93% accuracy, 93% accuracy, as opposed to SVM being 91. And even the area under the curve indicated that the K&N was better, with 93 to 91 here. Now, I think, or this is just in my analysis here, but because K&N is a non-parametric, like, and it's lazy, like it's a lazy learning algorithm, it just works best for smaller data sets. And so I think it worked a lot better in this case, just because the data set isn't as big, and because K&N definitely struggles when it comes to bigger data sets. As for the SVM,